the Hinsdale Wave Research Laboratory on the campus of Oregon State University. You'll remember in the news a few months ago, more than 28,000 people lost their lives in an earthquake and subsequent tsunami in Japan. You'd be interested to learn that Oregon is less prepared for something like this. I'm Ken Ackerman. Welcome to Comcast Newsmakers. Joining us now is Scott Ashford. Scott is the head of the Civil and Construction Engineering departments here at Oregon State University. We're in a research laboratory here, and this is very crucial to your research because along the shoreline of this tsunami basin, you can reconstruct coastal cities, can't you?
That's right, and actually we've put scale models of Oregon cities in the tsunami wave basin to look at the effects of the wave coming into the town and actually seeing how the different structures are going to affect that wave coming in and see how we can get, basically save lives from the tsunami.
And we've learned that Oregon is less prepared. What do you mean less prepared than Japan?
Well, if you look at Oregon, we have not had a significant earthquake for over 300 years. And if you look at places where, for example, Japan, Chile, where they had another large earthquake last year, they are prepared, at least in the effect, to look at the people are ready. They are aware of the risk and they take it very seriously. They have earthquakes every few years in those countries. Here in Oregon and the Pacific Northwest, the last significant earthquake was about a magnitude 8.5 to 9 along our Cascadia subduction zone, occurred 310 years ago.
Now explain a subduction zone where the two shelves meet.
Yeah, so a subduction zone is where you have two plates, and in our case we have the Juan de Fuca plate subducting underneath the North American plate. And those plates get stuck. And every few hundred years those plates break and the Juan de Fuca plate subducts or goes underneath the North American plate, causing a giant earthquake.
Not unlike the region in Japan?
Just like the region in Japan, just like the region in Chile, just like that region where we had that deadly tsunami down in Indonesia.
How would we fare here in Oregon with the coastal cities and inland if there were a magnitude 9 earthquake?
So if you look at a magnitude 9 earthquake, I think one of the biggest impressions that I've had is that the damage is so geographically widespread. So we're looking at the area that would be affected from the earthquake would essentially be from the Canadian border down into Northern California and from the coast all the way into the I-5 corridor. Now the tsunami is going to affect the coastline. Here in Oregon, we don't even have all of the tsunami areas mapped so that people are aware where the tsunami risk is.
But even if it were mapped, you're saying Cannon Beach and Seaside, folks would have no way to get out.
Well, that's the, if you look at some of the areas after the earthquake, which might last 3, 4, or 5 minutes, then we have about 20 minutes to evacuate. And there's some cities along the Oregon coast as well as up in Washington where you just physically do not have enough time to get to natural high ground.
A lot of people think of earthquakes as, well, the building starts to crumble, but you say there's a phenomenon called liquefaction. Is that correct?
Yeah, one of the things that I study is liquefaction and lateral spreading. This is when the ground, because of the earthquake shaking, the water pressure increases in the ground and it reaches a point where it essentially turns to a liquid. And you saw videos in Japan on TV where you saw sand and water just boiling up out of the ground. When that happens, one, it loses most of its strength. So you see a lot of bridge collapses as a result of this liquefaction and lateral spreading, plus causes houses to settle, buildings to settle, and it raises havoc with any of your lifeline facilities, water lines, sewer lines, anything that's buried in the ground, and then it makes the recovery effort so difficult.
Makes a structure such as this Wave Research Laboratory integral for folks coming in around the world studying what might happen. And we thank you so much for your time. Scott Ashford here at Oregon State University, some interesting stuff, and we will see you back here. This is Ken Ackerman. You're on Comcast Newsmakers. Make it a great day.